Welcome to the Lead Like Elon podcast. I'm your host, Tim Hampton. With me is my fellow SpaceX and Tesla enthusiast, Erastus Kipkirui Laboso. Today, Erastus and I will be discussing what Tesla AI Day revealed about artificial intelligence, full self-driving, and its future ambitions. Erastus, welcome to the show.
Thanks so much, Tim. Always a pleasure coming back again.
For me too. Let's start with a description of AI and its three main components. So we'll start kind of high level. You've got the neural nets, the training computer, and the inference engine in the cars. Do you want to break down what they do a little bit?
So we're going to start with the neural networks. The neural network. So the neural network is basically like just networks that brings data together, and then from there it generates it looks at the patterns of all these data, and then from there it inputs out data now to the other components of the computer that can now access and look at what happened here, and this happened here, this goes with this goes with this. So that is basically how simply I can put it. Yeah.
And so the other two components, the way I understood it, is what surprised me that I didn't realize about machine learning and AI and the way Tesla's approaching this. The cars themselves don't learn. That's the big surprise for me. You can take it on the same route over and over again, and it's like a cockroach. It doesn't remember anything.
Yes.
But if something goes wrong or if something interesting happens, then the theory is that either you intervene and say, this is important, and it goes back to the training computer, or somehow it recognizes that you intervene or things happen the way it didn't expect, and that becomes part of the training data. And so all the deep thinking goes on in the training computer, not in FSD. That was the part that surprised me the most, I think.
So basically what happens is, so while you're driving your Tesla there's a shadow mode, what do you call a shadow mode? So it's like it drives, it's kind of like trying to drive itself, but if you have not put it on, it just continues with that, it just kind of self-driving in a shadow mode. So when you intervene or when it does something that they shouldn't have done, then that data set is sent now to Tesla servers, where they now use this data of in over 1 million vehicles that they have outside there. And if it's most of the time it's in shadow mode, then it sends these critical data that they can see, why did this person intervene, or what happened here? Why did the FSD think that this was the right way? Well, the driver thought this other side. So this is a very critical component that when you look at and actually this is the reason why Tesla used the vision approach as compared now to other use of LiDAR and radar. Because for LiDAR and radar, it's just about distance and what is happening within the vehicle, but it doesn't give you the whole dimension. So if there is something that is blocking the vehicle ahead, the vehicle, if it's using LiDAR and radar only, they cannot know exactly what that is, but they will know that there's an obstacle ahead here. But what is that obstacle? It might be there's a car that is stopped or something. So this critical data from Tesla or from all these vehicles or these Tesla vehicles on the road, when you intervene during a certain FSD, and even when you're not on FSD, when you intervene, they will know okay, this is the issue, they send it there. And then from there now they use their computer. So right now they're using the NVIDIA chips on their server side to train their neural networks. Yeah, so that is where they do the training. After training, what happens is now this training, they now go do simulation, they train, they look at different angles, different things that can be done. And then from then they now send the data back through updates to the vehicles. And then they look at it again over. So this loop, I think the learning loop, it's called the learning loop. So you change something slightly, and then you look at it, what happens, then you get another data set, and then that is how you train.
So let's talk about one of the critical components here, and I think you used it by name, the Tesla Vision. Yes. What is Tesla Vision doing?
So Tesla Vision is actually, when you look at it, it's a simplistic approach to full self-driving. Because full self-driving, as Elon Musk has said several times, even earlier, I think from 2017 going onwards, that full self-driving is an artificial intelligence problem, because human beings, we use our eyes to look at the road, and then we use our brains to judge what can happen and what might not happen, right? So if Tesla has all these cameras, it means it's now through artificial, it's just a problem that can be used through artificial intelligence. Can we make our computers be intelligent enough to know that when this situation happens, this happens, then this is what you should do? So I think now from their data sets and from their training that they have been doing since 2016 or 17, 2016 actually, on when they say we are going to full self-driving. So from that data set that they have, they concluded that the only approach and the only viable approach to full self-driving, and the viable approach, which means viability means cost effective, simple, and it can be achieved over time, and you can like use the technology in any road all over the world. I don't know if it can happen in Mars or something, but all over the world, like you can use anywhere, not just some places which have been mapped, which has been labeled this way and this way. No, it can apply anywhere. So the solving of this problem by Tesla vision now comes in Andre Karpathy. So Andre Karpathy is actually this this amazing guy. He's an artificial intelligence guy, and I think even Tesla got him through one of the partnerships that they had with the university where he used to work. And then from there now he was told, okay, come and lead the Tesla artificial intelligence and vision approach team. So in the introduction of the artificial intelligence, actually AI Day, he said that 4 years ago when he got into Tesla used to use one picture per frame. So their neural network used to use only one image.
Yeah.
But then once he came in, he realized that, okay, what are the challenges that we are facing? Why are we using one input, whereas we have all these cameras? So they now started building on a great neural network that is going to put together all these data. And once they have all this data from the cameras, they have to make sure that the data that they have from all these cameras makes the vehicle know the situation around the vehicle, like what is exactly happening from this angle, this angle, this angle. And then they put them together in what they call the vector space. So the vehicle knows exactly what is happening in the front, to the left, to the back, every other and even inside the driver. So the camera in front of the driver can also monitor the driver. What is the driver doing? What is happening? So with that data set now, that is now what can I say? Like that is now what encompasses the vision approach by Tesla, like using all these cameras and putting these data together and then making output of these data, like what is happening within the vehicle at any given time. And this is not something that is just, it happens like in real life. Like as the vehicle moves ahead, the situation within the vehicle changes every single time. So now through their neural network training and stuff and things like that one, they now train and then they make the vehicle be aware that if this is happening and this is happening, what is going to happen. So the vision approach definitely for Tesla is going to be, it was cheaper. So the first thing, as I said earlier, was cheap. It's going to be very cheap because you just input all the cameras and then put your FSD hardware computer into the Tesla so that they process this data and send this data, and then the computer can make decisions based on these data sets. So it's cheap. And I mean, that is the most important thing, cheap. And then if you focus on that, you just like focusing on training a human being, training a young child. So artificial intelligence basically is training on something from the data that you have and keep improving on that data each and every training. The more data you get, the more you get better. Mm-hmm. So it's like a young child. So once that a child is young or small, they now start learning, touching here, saying this, falling down, coming. Like you learn like that. And that is what Tesla knew, that by using vision approach, we will be making the full self-driving, or the vision approach will be improving each and every other time, as compared to now the other aspect of radar, LiDAR, and those other components.
So you've raised a couple of interesting points. One thing I want to talk about some more is you kind of compared the process of Tesla learning to drive like the training neural nets, learning to drive like a
Yes.
child. And that
Yes.
was one of the things that really stuck with me from this presentation is how much, I mean, obviously the structures are different, but Andre even said we're making a cybernetic, I think an artificial creature or something like a cybernetic animal. And,
Yes.
for example, you know, they're making their life easier in a way that a human likes to make their life easier. So for
Yes.
example, the 360 camera.
Yes.
My sister has a Nissan I forget anyway, one of the larger SUVs, and
Yes.
it has cameras all the way around, but instead of presenting 8 different camera views, it stitches it together into a 360 surround view.
Yes.
And so that makes it easier for the human. You don't have to try and in your head put together 8 images. And so they're
Yes.
using an intermediate step that is actually quite easy for a computer to do, which is make this into a single view, stitch it together. They even do
Yes.
things like they said that the cameras in the cars were somewhat cockeyed. They weren't all
Yes.
perfectly aligned compared to one another, but that's fine.
Yes.
That's an easy job for a computer to reckon with
To
and
do.
solve. And then
Yes.
once you have that 360 view, they even correct for flaws in the lens. They correct for lens flare,
Yes.
misalignment, focus issues. And so they make it into one much better image. And then they can give
Yes.
that to the computer, and it's much less confusing to solve. And I thought that was really interesting.
Yes.
And they do things in the training, like they take scenes. So they had a problem with snow coming off a truck and you couldn't see what you were doing. And that was always
Yes.
a justification. I live in Canada, and it's a scary moment when there's a big chunk of snow coming at you
Yes.
and you can't see what's going on in front of you, but you do have a memory and you do realize that the car is still up ahead. You may back
Yes.
off the throttle a little bit. You may slow down because maybe they're slowing down,
Yes.
but you don't need radar to know that the car is still there. You just need a little bit of memory. And so
Yes.
they're actually teaching cars object permanence, like you do peekaboo with a child. You're still here,
Yes.
even though you're hidden, you're still there.
You're still there.
And
Yes.
it's amazing that we're teaching computers the same way.
Yes. And when you look at the example that they gave, actually, they gave an example whereby, so there was the snow that was coming, and then now they have these more than I think about how many, I think about 10,000 videos that they say they now get the same instance in different situations and scenarios, and then they train the neural network. And once it has been trained, when you compare the one that has not been trained to the one that has been trained, then you realize that it already knows the velocity in which the other vehicle is going, because the computer can look into it and say, okay, we estimate that this vehicle is moving at this speed. And then it gives it a block section so that the computer knows that this vehicle of this size is on this particular in this road, and it was overtaking another vehicle. So it already knows that. And I think that is the most important thing, that, as we said earlier, it's like a child. So it keeps on learning. And the good thing about Tesla, as compared to other full self-driving companies that are trying to achieve autonomy, is Tesla has these amazing data, quality data from different vehicles that they have on the road. They don't have to simulate everything. So
Right.
you find that data from simulation, when you compare to real life, are really two different things. And if you use data in simulation to train your vehicles, and then you use the real life data outside there to train your vehicles, which one is going to be better in real life? Sure. And I think that is so important. And I think when Elon Musk realized or knew that this is an artificial intelligence problem, and I think Andre also said earlier in the conversation that not I think the other guy, I think Ganesh, said that when Elon Musk said that this is an artificial intelligence problem, what do we need? So I think basically for Elon Musk, solving all problems starts from the basics. So what do we have? What are the limitations? What are the advantages of the computers that we have? What kind of computer do we need? And what are the resources that we do need? Yeah. And I think the main goal for the Artificial Intelligence Day was one, and the most important thing actually was not just to showcase the technology that they are having or they are developing, but to recruit people to work on this, because it's a big problem and it needs smart people who are looking at the vision that this is what we want, and we are going to walk through the clock. And I think that the difference between Tesla or Elon Musk companies as compared to other big companies in artificial intelligence, like maybe Amazon or Google, where people go there not to change the world or not to solve real world AI data, but probably most of them to make money and stuff. So I think that is the basic concept. And when you look at Andre Karpathy, I think that is the guy who even made Elon Musk realize that we need to go to vision approach only. Yeah, because you will be confusing your resources and actually misusing your resources if you need to input the data from a leader, from actually not leader but radar, from radar, and then for you to process the data from radar, and then also compute the data from the cameras and put them together and want to make decision on all angles from radar and then also from camera, it's going to even confuse the machine. And I think that is what they realize, that this is confusing machine and it makes the work slow. So it's better we just go for vision and solve the vision by using artificial intelligence, as simple as that.
Yeah, I will say that the presentation did a good job of convincing me that they don't need LiDAR, that they don't need radar, that they are able to achieve this with cameras. One of the things that came from that is, before it sort of seemed like magic. Now you can see that there are steps involved, and the more they work on those steps, the better it will be. So on the one hand, I felt like I was convinced it's going to happen. There's nothing magical. It's going to happen. It also convinced me that we're probably not there yet. So we'll get to predictions at the end, but it struck me that there's a lot of work to be done. But let's keep going through some of the components of the show. Let's talk a little bit about planning and control. I thought that was an interesting section of the presentation where they're talking about how they decide what the car will do, but also anticipating what other actors on the road will do.
Yes. So once we have this data set from Tesla Vision, from the Vision team, so once we have what is happening within the vehicle, now this data, once you know like what is happening within the vehicle is this and this, there's this vehicle, there's this road, it's going to bend this way and there. So once you know this data, you now send this data to the neural network planner, or actually to the planner. So the planner is now going to say, okay, the vehicle has to maneuver this way, or the vehicle has to stop, or as the vehicle has to go this way, or the vehicle has to slow down. Like the neural network planner is the one that decides what the vehicle does. And this is actually the most important part of as much as in the vision is so important, but this is the most important, because if the FSD decides to go this way and then the driver doesn't agree with that,
right,
that is now when it says, okay, no, this situation, what happened here? Send the data back. And then they retrain it, they put it back, and then they continue. So the neural network planner is actually the one that when you send the data to Tesla, when Tesla has trained the data, and then they are fully aware that this has worked in this situation that was a challenge earlier. They put it back now to the neural network planner, because it's this one that is going to decide whether the vehicle is going to swerve, it's going to maneuver, it's going to, like, anything that the vehicle does comes from the neural network planner based on the data that is there. So what happens is, and I think he said categorically that there's what we call the space and time metadata. So means that the vehicle still has the data of what is happening in the vehicle. So any decision they're going to do going forward, like if it's going to swerve, or if there is a stop sign that is saying 100-meter stop sign, for example, in the road, the vehicle will know that there's 100-meter behind us. And any decision we're going to make going forward is based on this. And all the simulation, the data labeling that actually I think Ganesh talked about was really amazing, because the vehicle itself recreates something like a simulation or like a game, and give it to Tesla Autopilot to play the game. So, and the game is the full self-driving. And I think that is shows you like how simplistic it is. Like if full self-driving is like playing a game, so it means that literally it doesn't mean like it's a game. No, it's something that is real life and stuff. But they're using this one to play in shadow mode or in real life mode to know that the vehicle thinks that, or the neural net planner thinks that this is what should happen. But is this really what will happen? So if you are driving, the other driver, and you say, no, this is not how it should happen, like, or this is the right way to go. So it knows that in this instance, for example, there's an instance that they gave out that they have data from different vehicles going through the same route over, and they put together all these data together. You can have about 10 vehicles coming in together, and then they put together this to know that in this situation or this road is like this, and in this situation this is what should happen. So these are among the things that they're developing: the simulations, the manual labeling, the auto labeling and stuff. So I think it's so important for the vehicle to know what to do and what not to do, and the neural network planner is the one that is so important in all of it. I think for me, in all of it, as much as the neural network training is so important, but also how the neural network planner sets out and get the data from these vehicles and input it back to Tesla. I think that is so important to the whole concept of the Tesla vision approach.
Yeah, there's a couple of ideas in there. I'm following the order that the presentation was in.
Yes.
I think, but it seems to me that labeling should almost come before planning and control. I don't know if I've accidentally reversed them, because the labeling is the understanding of the world around you. That's a curb, that's a car, that's a stop sign. Once you have that picture in your head, and as you pointed out earlier, you have to transform the picture, the 360 camera view, into vector space. So now you have an understanding, like a bird's eye view of where everything is. Don't hit that, that's coming at you, that kind of thing. But you have to do that labeling first, and then you can begin your planning and control. And the other thing I thought was really interesting is this, they said it a few times in the presentation. There were things we used to do in C++.
Yes.
Now we have a neural net to do.
Yes.
So they're becoming less explicit in terms of how they're instructing the car. They're letting it learn for itself. And this reminds me, I don't know if I think we may have spoken about it before, but this was, I think, 2 years ago. There was a controversy because the Model 3 didn't have a rain sensor, a hardware rain sensor. And so the wipers were not automatic. And then, of course, the controls inside the car are all on the screen. So it's a little awkward to turn on the wipers and everything.
Yes.
They said, well, no, it will learn when it's raining.
Yes.
And I first of all, it's good for a car to know when it's raining because it affects how fast you can turn, how fast you can stop.
Yes.
So how much distance you want to leave between you and the next vehicle. So it has an impact there. And then of course it also, so it's multi-purpose, right? It's another awareness for the car, and you don't have to program it. You let it learn. Yes. So you can apply, you can see that they're also trying to do that. Like they're not like a GPS. The GPS says turn left, turn right, but it's all sort of, it's all code that works it out. Yes. But in the Tesla cars, they're applying more machine learning to that as well.
Yes. And I think that is the importance of their vertical integration, like of the FSD. So when they change something on the FSD hardware, it's going to affect how everything else is affected. So if they think that the neural network approach is the right way to go in making the vehicle learn, then they just use it and go with it as quickly as possible.
Yeah.
So, but the main thing that you said was let the vehicle learn. Once it learns, it knows that this is the time it's raining. This is what is happening. Like the self-awareness of the vehicle should come out naturally. It shouldn't be something that, okay, you said, tell the vehicle, oh, it's raining. Like, let me have this button. Like, and I think after a while that problem was dealt with over the air updates and stuff like that one. So I think that is also another aspect of full self-driving that is so important to Tesla. Once it has learned, it's now given to the different people. And I think they say that mostly they learn from company employees and also the beta testers. So if you look at Elon Musk, or the tweet that Elon Musk said, like I think 2 or 3 days ago, he said that the one that he's using, the FSD beta that he's using, is different now from the one that the other public has. So meaning that they have different data sets from different people. Like now the FSD beta, the now the employees for Tesla, if I'm not wrong, and then the FSD beta team, and then also now the real world data that is happening out there.
Mm-hmm.
So the vehicle, actually Tesla vehicles learns faster than any other vehicle. And when you had actually what Elon Musk said was Tesla going forward will not just be an electric vehicle company. It will not be an electric vehicle company. It will be an artificial intelligence company.
Yeah.
Which happens to be an electric vehicle making company. Because literally when you look at it, it's like Tesla vehicles are robots on wheels,
right?
Basically. Yeah. So I think that is the other aspect also that is needed. But as you were saying, is that anything that is happening, the vehicle has to know that this is happening and why it's happening. Yeah. And also the bird's eye view and the labeling that you were saying that it has to have happened earlier before we get there. But I think the labeling, when you label now in the neural network planner, what happens is that the neural network planner, so if you label in the neural network planner, once you have the bird's eye view of the vehicle, and the decision has to be made by the neural network planner. So if it's a cone, like a cone in the road, it's already labeled. So the neural network planner already knows this is a cone. Mm-hmm. So if you would have labeled it probably, let's say earlier, the model, actually the AI, artificial intelligence algorithms model that are in the neural network planner will not know like this is a cone. But when you do it now within the neural network planner, it will know that this is a cone. This is this type of vehicle. This is a wall. This is a vehicle that is standing. So I think incorporating all these, that this is a vehicle that is, let us say it's a parking, it's going through a road where vehicles are parked alongside the road. So once that has been labeled as a parked road or a vehicle that is not moving or the velocity is not moving, then I think labeling it in the neural network plan or in the neural network planner, I think is a good thing, because the neural network planner will make decisions based on these labels that has been done within the neural network planner model.
What did you get from the part of the presentation where they were talking about automatic labeling? What how does that work? Because I know that they talked about having 1,000 people in-house, which is unusual, right? They're hiring people, which I'm sure quite expensive. They're in the United States. They're, probably in California, which is not a cheap place to live.
Yes.
And they've got 1,000 people looking at, and of course they're being as economical as they can be, because they're really distilling the information into what they call 4D space. So you've got the vector space, you can run the clock back and forth and go, that's a post box, that's a cow, whatever. So they're being economical with it, but then they're also trying to auto label as well. And I guess what's confusing to me is they're talking about auto labeling in the training computer.
Yes.
The neural net can already label what it can already label. So the car's not learning, the training data is learning. Well, how can it learn automatically? Did you understand that part?
So I think what they said was, I think they started off from, like, they used to have a third-party employees, a person from that party who used to label for them, but it used to be very slow, and as much as it was cheap, it was slow, and the quality of the data was not right. So I think for you to achieve FSD, the most important thing is, as much as it can be expensive, but what is the quality of the data that you're having? So the quality also matters. And so when you talk about automatic labeling, so they used to use that was manual labeling, and then they continue with the manual labeling. Now that was in 3D, and then they came to manual labeling in 4D. And then now you now go to auto labeling, which is automatic labeling of the surroundings. So what I learned was that this one usually happens in simulation. So they label these things in simulation. Automatic labeling happens in simulation. So you have whatever is happening within the vehicle, that this is this, and then they now label one after the other, alignment, like aligning. So when you already have the data, if you know this road is not aligned or this is this, so Once it has been done manually in 4D, then now the system already knows that this is this. So as the vehicle, for example, goes, it does automatic labeling of that specific place the vehicle is going through.
Mm.
So I think for me that was it, but I think it's also something that they're still imagining, because they use now the various data that they do have to train the automatic labeling of the neural network planner. So I think also another thing is, if you have different data from different sets, and then manual labelers have done their part in 4D, then I think the remaining part for the vehicle to know whatever is happening on this other side or in different scenarios, it can work on that on that aspect. So automatic, even to me, it was not so clear, but what I got was that this one is usually done in simulation. So I think it happens mostly in simulation.
Yeah, you're reminding me actually, because they showed a couple of examples of a complicated intersection.
Yes.
And they showed them laying on top data from several cars that went by. And I think what you're making me understand is if there is a stop sign and many of the cars passed by and didn't correctly label it because it was a funny angle or it was hidden behind a tree or whatever. At least one car is going to go by and automatically label it successfully, or somebody has to manually label it. But now you can train the neural net to understand it from all different circumstances. And so the next time the cars, if they get that neural net, go through that intersection, they'll be more successful at recognizing everything in that intersection.
Yes, and knowing this one is this.
Sorry, I cut you off there. Go ahead.
I'm saying, as this one got, like, as you were saying, that if another vehicle goes through this or it was in a different angle and then no, this is this, then it automatically labels that one as a stop sign, or there's a stop sign there, or there's a this sign here, or there's this wall here, or there's these cones here. Like, I think that is what happens technically, because I think even the person who was explaining this didn't put it out very clearly. I think they did it quickly. Like, that is what I thought. Like, they moved on to the next quickly without explaining.
We need somebody to label the show for us.
Yes.
Yeah. So one of the other important things, I always assumed, for example, that one of the advantages of having a Tesla fleet reporting back centrally is that the Tesla car any Tesla car that saw a telephone pole on the road could say to every car behind it, watch out for the telephone pole.
Yes.
But that doesn't seem to be happening at all. It will share the data because it's an unusual event. It will share it with the training data, but the training data is going to include what to do if you see something like a pole on the road. You don't need to remember that it's there. And as Elon is fond of pointing out, the car's reaction time is incredible, right? It'll recognize that telephone pole and it will know what to do and will stop before it hits it faster than a human.
Yes.
It doesn't need to warn the cars behind it. They can all come over the hill and see the same thing and react correctly. And this is very different from the Waymo approach, which is, okay, there's road work. It'll sort of share that with it. It creates a map that includes the fact that there's road work there and how to navigate it. It doesn't react independently at all.
Yes. And I think that is exactly so. I think, as we were saying earlier, the child example that we made about artificial intelligence, actually the neural network training. So what you do is, it's usually very good for any situation that you go through or that happens. Everyone reacts differently, but with neural network training, and the same training goes to all vehicles, the reactions should be the same every single time. And I think that is also the reason why the Waymo approach, I think, to me, is a fail from the word go, because you have to label everything for the other vehicles to go through there. But for a Tesla vehicle, I can have it here in Kenya and just get to the road with it, and I'm okay, like, without any labeling. Like, why should you label it? It's like telling the child, no, walk on this path, don't go here, don't. Like, it just, like, some situations will come out of these situations, or of these like the situation that we're talking about in a road. Like the way another vehicle sees is different, or what is the reaction? What should the vehicle do? And if it doesn't do that, then you now get back to the drawing board and say, okay, what happened here? Or why did this happen? Then you build on that. And the other vehicle, that when it encounters like not the same situation, but maybe a similar case, or a similar, not so similar situation, a situation that is nearly like that, what does it do?
Yeah.
I think that is the basis of it. But for me, when I compare with the Waymo approach is like spoon feeding a child and expecting them to go out there and make things happen. It's so hard. They will find it so hard to function in real life. And I think that is what has been hampering them. And also their approach is they don't have a lot of vehicles that are going on in the roads to have this data, this import. I think the quality of the data is what we were talking about earlier in terms of labeling and stuff. So if you label the quality data, it helps the neural network in terms of how it's going to perform.
The next section in the presentation was simulation. We've touched on that a little bit, but I think one of the interesting things about simulation was that, in the Q&A, Elon was saying, well, we don't have very many examples of our cars running people over, and we don't want to. So we have to simulate some events, some near misses, and what to do if you can't avoid the accident. We have to create that simulation so we can see what the car will do and make sure it does the best possible thing. Did you learn anything else from simulation? What other kind of examples were they coming up with for simulation?
So the example that they came out with was like a situation where there are chaos in the road, for example, and people are running on the street.
Yes.
And Tesla vehicle is going. What do you do?
Mm-hmm.
These are situations that doesn't happen on a daily basis.
Right.
But when it happens, I think they say that simulation, they use simulation basically to train on these edge cases that you cannot find in the road. But it doesn't mean you will never get it. And that is so important. That the simulation part is so important. So if the vehicle is to hit, can it hit one person, or hit a vehicle with many people in? That is something that you cannot find it in real life, but you have to simulate these data so that the vehicle knows that this is the best decision that you can do in the worst case scenario. And we don't have any worst case scenarios.
I want to pick up on that because Elon was asked explicitly, how do you balance between the safety of the occupants of your cars and pedestrians and people in other cars? And he did not answer. He just said the car is awesome. It has amazing reaction time. He basically said, don't worry, it won't get into accidents, which is not true. There will be occasions where the tire blows out or you get hit by one car and you're out of control and you have to make the trolley problem. Like, do you hit this people or this person? And I think that the same logic, just like when you go around a corner in a Tesla, it's thinking in terms of cost. It's trying to minimize costs. So how jerky is it for the occupants? How close do I come to other cars? How much electricity do I use? It has a table in its head of what's the most important thing and how do I get most. Well, I'm sure there's something in there about protecting the occupants versus protecting somebody else. He didn't say what that was.
He didn't say, because you can imagine what the media would have said on that basis, because at the end of the day, these are the things that they have done in simulation, and the media can take it out of hand to say that a Tesla vehicle has been designed to protect the occupants only, but the pedestrians are not. Like, those are the situations. I think Elon Musk had an answer to that. He just said, no, I'm not going to answer. Going to answer. But the thing is, I think the vehicles have been trained to what I think is the vehicle, as much as in the safety of the occupants is looked into, also the safety of the pedestrian is also important. So I think they put it together in that, but the simulation aspect of it, I think they have simulated on this, and I think people who does this are actually ethical people, and they're amazing team in Tesla who use, as much as in you want to protect your people, but at the same time, if it's something that is not ethical, then I don't think anyone would approve that one, even at Tesla.
Yeah, I think you're
for
right.
the
I
sake
don't
of
think
it.
that deliberately go and say, mow down those pedestrians because my brakes aren't working and it will protect my occupant. I don't think
Yeah.
anybody would explicitly write that in, but I think that they're relying on the idea that the goal, and he said this, prime directive is don't crash, don't hit anything.
Yes,
If you don't
totally.
recognize it, I don't care if it's a UFO, I don't care if it's a big octopus, don't hit it.
Yes,
And
yes,
so you could argue that there is no calculus there. There is no trade-off. It's going to do whatever it will do whatever it can to avoid the accident. But what I think
yes,
what you won't get a trolley problem, you get a Titanic problem. My interpretation of the way the Titanic sank was
yes,
they could have hit the Titan they could have hit the iceberg and survived
yes,
that, but they didn't
yes,
want any accident at all.
yeah,
And so they turned as hard as they could and scraped along the side. Now
yeah,
that I think that story has been told often enough that it's not quite true, but let's
yeah,
pretend it is. Like, let's say that
yes,
these are the choices we could make: aiming for
yes,
zero or accepting some damage. And the way he's describing the prime directive implies to me it's going to Titanic. It's going to
yes,
avoid, with every possibility, an accident and maybe create more accidents. If you
yes,
see what
yes.
I'm getting at.
Yeah, I can see that. So the main thing though is if there's an accident in front of you, what does a Tesla vehicle does?
Mm-hmm.
Stop, stop, or move aside. So when you look at most of the videos that are out there for Tesla avoiding accidents,
Yes.
what does it? Does it stop or does it avoid the accident? Mostly they avoid the accident. They will
Well, I've
swerve.
seen both. I've seen
Yeah.
both. I've seen samples of cars coming into your lane and it'll
Yes.
move out of the way.
Yes.
And presumably, I mean, this is where the reaction time comes in. It's aware that there's not a car on the other side,
Yes.
right? I've also seen an accident where, or a near miss, where the car
Yes.
was about to leave an intersection and a car came straight through the intersection against a red light, and the
Yes.
Tesla stopped to let the car go
E-
by. So
Exactly. So
I've seen it do both.
yeah. So I think the most important thing is what is the damage that what is the best possible scenario that you can do as a vehicle, or what that can happen at that particular instance, depending on that situation. So basically, I think at the end of the day, the Tesla vehicles are more intelligent than we are as humans because we use emotions. You know, sometimes we use emotions. Like, what am I going to do with it? But when it comes to a computer, it will do the best possible scenario because sometimes you don't know. You're like emotional. You want to hard the brake. Can you go? Can you swerve? Can you do this? Like it's a near second situation that you need to process it as quickly as possible so that you can do anything. So, but I think Elon Musk and Tesla team can solve this problem easily because human beings are prone to a lot of errors in the roads. Basically, yeah, a computer can be drunk. You can
True.
pass a red light. So if a computer sees a red light, it's not going to go through. So
Right.
I think that is something that is. So for me, though, I think there would be accidents that can happen. And the more they simulate on these situations, the vehicle gets better on this. And when they do this in simulations and they got a real life like situation or a real life video data that they have from their vehicles and use that one out to use in simulation and also the real life data, I think they're going to come up with something so quality that in case of any funny situation that happens, the best decision they can make is going to be the outcome.
Yeah.
And yeah.
Well, I think they're going to have to admit what their ratios are, what their when they calculate cost, they,
Yes.
they must be calculating a cost per occupant and per somebody else on the road. They're going to have to admit that,
Yeah.
because otherwise I think there's going to be, because I am firmly in the camp that says probably 2 years from now, I'm getting into my predictions too early, but I think
Yeah.
2 years from now, we're
Yeah.
going to say that full self-driving is safer than humans, like with no steering wheel,
Yes. I
right?
agree totally. Yeah.
But that doesn't mean it's 100% safe. And
Yeah.
if the car chose to protect the occupants instead of my son on his bicycle,
It's going to be
I
a
might
problem.
sue, and then it's going to
Yes.
come out one way or the other. So
Yes.
um, the next section was on hardware integration. And my
Yes.
interpretation of that was basically how they take all the lessons in the neural nets and jam it into the car. Is that correct? Is that your interpretation?
Yes, yes, most definitely. In the integration means that so once you have all these data, once you have trained your neural networks, once you know what is the situation the vehicle can do in the neural network planner. So now you take these into now the FSD. I think that is basically the FSD hardware that is in the vehicle. So once the data is there, that is it. You just integrate it and then see how what happens by over the air updates and stuff like that. But the most important thing in terms of hardware integration and that I saw was they were talking about making sure that the next Tesla chip, the FSD, I think hardware 4, if I'm not wrong, is going to process real data and become quicker than even the other the FSD hardware 3 that we have at the road right now. And that integration is important in terms of, and I think they say that the vertical integrations makes it easy for them to test these technologies because they do these, they have these softwares in-house.
Mm-hmm.
And if there's any change that they need to do in terms of let us say in terms of processing of all the camera data and also the hardware data. So if there's an issue with the camera, because the camera has to put this data into to make sure that all the vehicle reads whatever is happening within the vehicle into the hardware chip, because it's the hardware chip that is making these decisions at the end of the day. It's something that is just going to happen within the computer that is in the, so whatever situation happens within the vehicle will depend on how the software has been integrated. So I think mostly it's about software integration or the software stack integration of all these training networks that they do have. So, right. But mostly I think the most important thing was they were saying like the good thing that they do have is the vertical integrations of the whole thing, because you can easily change. And when you look at what Kapathi said, was it Kapathi or I think Ganesh said that the fact that they can do this in-house is so important.
Yeah.
Even the chip that they were talking about, the D1 chip, so that if there's any change that we can make from this, from the like the input of data, any change that we do in the neural network, and the output that we expect. So what are the outputs that we expect? Can the hardware 3 be able to process this vast amount of data in a given second?
Mm-hmm.
So if not, then they will have to move to the hardware 4. And I think the hardware 4 will be okay. Will be ready by, I think, next year, if I'm not wrong.
Yeah.
So once next year gets here, then meaning all the vehicles that are going to come, like the Cybertruck, the Model Ys, 3s going forward, will have the hardware 4. But still, you can get the hardware 4 by just going to a Tesla shop and then they remove it, they put the 4 there. So
I want to talk about that because that's somewhat controversial. So I want to come back to that.
Exactly.
But before we get into sort of the controversies and the predictions, I just want to finish through the presentation.
Yes.
But before I even do that, because I want to get to Dojo. Of course, we both want to talk about Dojo. But I just wanted to touch again on how much AI is just like us. You know, that it has to learn by doing. It forms its own patterns. But I don't know if you're familiar with, I think it's Daniel Kahneman's book, Thinking Fast and Slow. Have you heard of this book? It's a fairly famous book. And really what it's trying to do is it's saying that if, when we're driving, you know how you can turn the radio and you're not really thinking very much about driving. It's natural, it's automatic, right?
Yes.
But then when you're lost, you turn the radio off and you're super focused and you're really processing what's going on around you. And he calls these two processes, one where you're really deeply thinking about what's happening, that's system 2. And things that you're just doing automatically, system 1. So I imagine you've been driving probably 5-6 years, 10 years. How long have you been driving?
Probably, I think 4 years now.
4 years. So it's probably very familiar to you. You probably don't, you can drink your coffee, you don't have to think the whole time. right?
Yes, yes,
It's only when something surprising happens that you really have to think. And what's
yes,
interesting to me is that there's and even in his book, Daniel Kahneman says, I'm not
yes,
suggesting that's how the human brain is organized,
yes,
but it is how human thought is organized. There's things we do without thinking, and then
yes,
occasionally that goes really badly wrong.
yes,
And we have to think some more to come up with a better solution, and then that becomes automatic.
yes,
And I thought that that was a really interesting parallel with the inference engine, the computer in the car, which is doing
yes,
things on a pattern that it's already imposed.
yes,
And then when it gets something wrong, that's do deep thinking, and it does that in the central computer, in the training computer. So I thought that was
yes,
interesting.
yeah,
The other thing is this: they never said it out loud, but they talked about how eerily accurate its predictions were. Like it might see a little bit of a handlebar and know that there's a bicycle around the corner. It can figure things out. Or if it saw a car beside it,
yes,
it can see through its windows and see there's a bicycle there. And it knows that if it tries to make a turn, it might hit a bicycle. So be careful. There's probably, like it can really predict the future.
yes,
But they also talked about overfitting. And I'd never really heard this expression before. I looked it up, and it's
yes,
basically when the computer is only able to react to things it's really actually seen before. So it's not really learning; it's just doing flashcards. It's just remembering.
yes, remembering what happened.
And it's sort of like deja vu,
Yeah,
right? That deja vu is when some things are in the exact pattern from before.
yes,
And the
yes,
danger is you're going to think the same conclusion applies. But
yeah, that
really,
it
you have
happened
to be,
earlier.
yeah, but you have to be more general. You can't rely on your memory. You have to rely on what you see now. Because when you come around that corner, there could be a telephone pole. So you
Yes,
can't approach that corner too fast to break, right?
yes, yeah,
It's an intelligence. It's not a map, which I
yeah,
found really, really surprising. They kept emphasizing that.
yeah.
Um, Go
True,
ahead.
true. And they say that there are things that the computer does than the way we do,
Mhm.
like in terms of velocity of the vehicle that is ahead of you. Like the vehicle can look into like further ahead, like three vehicles in front of you, and know that this is what is happening. And
Yeah.
if that is what is happening at that particular time, what can happen is this. And I think human beings are not wired that way. Like you can look at three vehicles ahead, you can say, okay, the vehicles are still, so probably there's an issue ahead. But the computer can know that, okay, there's an issue ahead, and this one is what can happen. These are the situations that we can do to avoid any issue coming up from this.
Well, I'm gonna challenge you a little bit on that, because
Yes.
one of the things I couldn't imagine a computer doing well is
Yes.
interpreting what I'll call body language. Like
Yes.
when you come to an intersection, and humans are terrible, we never turn on our turn signals, but you
Yes.
can tell because the car is like 5 degrees this way, it's going to turn that way. You can
Yes.
tell because they roll right up to the intersection, they want to go first. So
Yes.
if they're slightly this way and you're waiting to come straight, they're going to cut you off. There are things
Yes.
you can read. And if they see you and change their angle a little bit, they showed an example of that. They showed
Yes.
that basically it's like when the dogs approach and one kind of
Yes.
bows his head, it's like saying the other dog can go.
Can go.
Okay.
Yes.
Yeah.
Yes.
So
Yes.
the cars are learning body language in a way I thought that would be the big problem. I thought the cars would be so deferential. They'd be like
Yes.
the beta dog and never get to go through the intersection,
Yeah.
but they are learning to be assertive.
And I think that is the most important thing about this, like the AI that Tesla is using in its FSD, that it's learning a lot of things and it's becoming more human-like and
Mhm.
human-like. As much as they're becoming human-like, they're even becoming better than that because they can easily predict what can happen
So
faster than human beings.
I have
And I think, yes, you
well,
can go ahead.
I'm waiting to hear reports of people who
Yes,
own Teslas complaining that
yes,
other drivers are cutting them off because they know that the Tesla will react in time. Like you can
true.
play chicken with a Tesla and win every time.
It will give you a way to go.
Yeah. So I
Yeah,
wonder if people are going to figure that out and take advantage.
probably they will do that. Like, but I think the more I think another issue that we do have, I think the only challenge that Tesla is having right now, I think right now Tesla is in a good level or in a good place to solve the artificial intelligence problems and make self-driving. Even the regulators can say, okay, self-driving is good. And it's through the results of the Tesla AI or Tesla full self-driving that will make governments say, okay, this is okay, and it's good. Because situations that we do see and look at in a lot of like online, because every day when I go to YouTube, when I come to YouTube, for example, I look at like I think about nearly 6 to 7 Tesla videos every single day. Some are for the videos that are happening. I go to Twitter, I look at different, like whatever people are saying, the videos that are on Twitter. Like there are a lot of things happening that is really changing the way people think about artificial, like full self-driving, when compared to previously, like 3 or 4 or 5 years ago. The main perception of people with full self-driving was, I cannot trust a computer to drive me. But right now, if you have a Tesla, you can just say, okay, I'm going to go full self-driving, and you're okay with it. And you don't have like any doubt that anything can happen. If anything happens, then you can take over. But in the meantime, you are training the neural network to get even better and better and learn. And I think it's from these that it will lead to regulators say, okay, as much as in people still have doubt and fear on this, but it's going to be a good thing. Mm-hmm. And it will depend basically within the next, let us say the next 5 to 10 years. It will depend with probably in the US, people will be in power at that particular time. Are they going to allow Tesla to continue or to accelerate in their efforts of the aggressive efforts of full self-driving? Yeah. Or they're going to hamper and say, no, this is still dangerous and we have not seen the technology working? Because if that is the issue, then the more the Tesla vehicles are out there, the more data Tesla has and the more quickly it learns. Mm-hmm. And the more it changes the people that are out there. Because if you have a Tesla and you're my friend, I get into a Tesla and you use self-driving to drive it around, what am I going to think? It will change my mindset of self-driving. Yeah. And I think that is the most important thing that is happening right now. As much as in Tesla is retraining and training the neural networks, it's also changing the way people think about full self-driving. They're trying to make it not so big of a deal, that it's something that happens automatically. Because when you are in a lift, what happens when you are in a lift? Sure. You don't think that the lift is going to fall, right? But when you started getting into a lift, what was your thinking? Can it fall? You were scared. But I think at the moment people are still scared. But as time goes by and Tesla vehicles continue increasing and people continue using FSD, then in itself, it's going to change the way people think of full self-driving. And that is so important.
So before we finish the review of the presentation itself,
yes,
we should talk about Dojo.
Yes.
Now, when I first heard the term Dojo, I actually thought the training computer was Dojo, but this is the next generation, the next computer they're going to rely on for training, or at least they hope to. They haven't built it yet. But as Elon said, when the training people say, turn off the old computer, we want to use Dojo, then they know they've succeeded. So what is Dojo and what are some of its design features?
So Dojo is basically a supercomputer. Actually, once it's here, it will be the best supercomputer out there. I don't think like that is specifically built for training of neural networks, especially for full self-driving and mostly Tesla data that they are going to do. But to begin with, the Tesla Dojo supercomputer. So what are the aspects of neural network training and artificial intelligence? I think it starts with the compute power. What is the compute power that is needed? The performance of the compute, the performance of these chips or of the servers that they are going to use. And then costs. What are the costs in terms of power usage? Right. Or what usage of power. So when Tesla started off, the challenges that they had in terms of their training was that one, like the computers that were there or that are still there, in terms of power usage, in terms of costs, in terms of the amount of data they can have in these computers to train, is not big.
Yeah.
So Elon Musk himself actually told the team that, what do we need? We need this and this. So make it happen. Work it out.
Yeah.
You have all the resources, make it happen. We need a better computer, so a better supercomputer for training and for our algorithms or the neural network models that we will be using to train the full self-driving.
Yeah.
And one that was done now, they now started working on it. And there we go. I think he showed us what are the components. And the chip itself, the D1 chip, what do you call it? I think the Dojo supercomputer, the D1 chip, is in terms of performance, in terms of power usage, and in terms of the costs, or actually the cost, and also in terms of the space it's going to take. Because when you look at server farms, most server farms, they are big data centers. But the Tesla supercomputer takes 5 times a small amount of space as compared to the normal data centers. So it's going to not just be costly efficient, it's also be high performing. I think up to 5 times performance than the chip that we have. And the NVIDIA, I think it's the NVIDIA that they're using at the moment to train their neural networks. So as much as they're using the NVIDIA, they knew that we need something better for the data that we have. And that is the good thing about integration, is that you know the challenges that you're facing. And instead of making NVIDIA or a third party accelerate the development of their chips, you do it yourself. And I think that is how Tesla got into the full self-driving chip. They also used to use as a chip from, I think, NVIDIA. Then they said, okay, what are the challenges? These are the challenges. So I think the D1 chip is going to be the best supercomputer. And I think this one is going to make Tesla full self-driving a reality.
I agree. There were some
100%.
What's interesting to me is, first of all, that they did build it. So they are committed to, or they did, I shouldn't say they did build it, but they intend to build it. And I don't have any doubt they will build it.
Yes.
But it's an admission that the approach, that the hardware they have available to them now isn't cutting it. Yes. So on the one hand, it makes me more confident. On the other hand, it makes me realize it's going to be a little later than we would like. Like, I think some of us, including me, have been thinking it's just around the corner. I don't think we're quite there yet. But let's do a little pretend math, because we don't know what this whole thing is going to cost. But I would be surprised if it wasn't $1 billion to build this exopod, this big first version Dojo. $1 billion. But that they're going to make what, 2 million cars next year? So that's only $500 a car.
Yeah.
And they're charging $5,000 for full self-driving. So yes, when they succeed, it's going to be a money machine.
And the thing is, the thing that people don't see is it will not just specifically be used by Tesla vehicles or by the Tesla team, artificial intelligence. It can be used for other purposes also.
We're going to get to that.
Yes, later. So, but what is going to happen basically is, I believe, so Tesla last year made, in terms of revenue, they generated a lot of them. Profits, they had profits. And for Tesla to raise capital, if they are going to raise capital right now, they can raise a lot of capital. Yeah. With over 600 billion valuation. It's easy to raise capital than it was 3 or 4 years ago.
Sure.
So I think they can even say that we are going to outsource the production of these data center chips. So we are not going to do it. We are going to outsource. So Samsung can do it the way they are doing the FSD chips that we are using at the moment. Mm-hmm. And it can be easier. That would be the easier way. But the most important thing is the performance of this chip.
Yeah.
Are these chips going to be efficient? Are these chips going to make Tesla achieve full self-driving? So I think that is the most important thing for them. I think they are testing right now. I don't think that they have not produced these things. They have these things, but what they are doing is they are testing. Mm-hmm. Because if he had one with him, He showed it. A good one, a good one actually. A wall.
Yeah.
So if it's going to be all those tiles, so the D1 chips is going to be formed into like 362 can form a tile. Then that tile can be put together. I think about 600 of them to have that one big tile, and then you input that one together.
Yeah.
So you find that it's going to process, not just process data, but also brings data back simultaneously, like the outcome of this process or of the training. As much as in your training at the moment, you also simultaneously doing what? Bringing the data back, like this is the outcome of this situation.
Yeah.
So
Yeah. That I thought was a very interesting. I mean, that Russian nesting doll, like this fits in this, fits in this, fits in this.
yes,
But what
yes,
was interesting to me is how much focus there was on keeping things in a plane, so
yes,
two-dimensional, so that
yes,
they can click together and have extremely
yes,
high bandwidth with one another.
yes,
No components interfering, no wires, no cooling fins. Everything can connect together because it's cooled orthogonally. It's top and bottom.
yes, yes,
The
from top,
power
yes.
comes in and the cooling goes out. I
Then
thought that was really interesting. And even like I'm sure any chip designer would be conscious of this, but it struck me as thinking along the lines of first principles, this Elon idea of, well, what is
yes,
the basic problem here? And they described the amount of time it takes at a certain clock speed for
yes,
a signal to go from one end of the chip to the other. And they
yes,
made sure that the chip was small enough
yes,
that it could make it from one end to the other during one clock cycle.
yes, quickly.
Yeah. So, I mean, all of this is really being done and then they even said things like they multi-thread, which means they can run four processes at once. So, let's say you and I are I'm doing a crossword puzzle and I'm like, what's a three-letter word for a feline animal? And you think
Yes,
about it and you say cat. But
yes,
meanwhile, I can be working on three other questions while I'm waiting for you to
yes,
tell me, right? So
yeah,
it,
yeah,
it, it reduces delays. And there's so much thought that goes into making sure that you are able to run full speed and still
yeah.
communicate around. I thought that was really interesting. I'd never seen the inside of a computer design like that before.
Yeah, even me, that is exactly what struck me. Like you can work with this data and also send back the data as you work on something else.
Yeah,
So,
it's pretty
and
cool.
I think that is basically like it's going to make the neural network training by Tesla to be faster,
Mm-hmm.
more efficient, and also when they scale. So in terms of scaling this data center, if it gets to scaling, how is it going to happen? It's going to be very fast because they understand that this is what happens, this is what happens, this is what we need. And I think also another thing that we like that came out from the event was that Tesla is working on something that is specifically related to the problem they are facing.
Yeah.
And like now, let us say NVIDIA is a multi-purpose chip. The chip is multi-purpose. You can have the chip and do whatever you want. If you are self-driving, if you are in other data analytics and stuff like that one, you can use it in different ways. But for Tesla, the problem they know is this is the problem, and this is what we want to solve from this thing. And that is the most, I think that is so underrated that people don't see it that way, that it's a chip and a data center, the data center chips that is specifically designed to solve a problem that Tesla is having. That is for training all the camera data that they are having from their vehicles.
Yeah.
Yes. Yeah.
I think the other thing, you said you were on Twitter. I was on Twitter too, and I found
Yeah.
myself um, in a group. The trouble with Twitter is
Yeah.
there's people who say one and people who say zero, and they don't
Yes.
talk to one another. Because if you go to a group that says zero and you say one, it's a
Yes.
pylon. You're an idiot. What's wrong with you? How could you be so
Yes.
stupid? And so it's really hard to have a conversation on Twitter.
Yes.
Um, but people are saying, like, as if Dojo is going to work. Elon
Yeah.
fails at 98% of the things he ever says he's going to do, is what one person said to me.
Yes.
And what's telling to me is
Yes.
They're already working on version 2.
Of the
What
chip.
makes you think they're not going to finish version 1?
Yes.
Right? These are
Yes.
people who are, I mean, there may be a huge gap between what they say they're going to do and what they've done, because
Yes.
they're ambitious.
Yes.
But there's not that big a difference between what they said they were going to do and what they have done.
Yes.
Now, full self-driving is taking longer, and
Yes.
there is a controversy around the hardware. I still want to come to that.
Yes.
But what's amazing, the reason I bring up the amazing capability they're building, and the fact that there's a version 2 in their mind already,
Yes.
is you started to talk about this earlier, is the idea that, well, when they get full self-driving working, they're not going to devote the entire dojo to that.
Yes.
There's going to be all this extra capacity. And they're even trying to hire, as you said, the AI Day was a recruitment event. They're going to get all these AI people excited to work with Dojo.
Yes.
What's next? What are they going to apply all this machine learning to? Lay it on me.
Yes, I think mostly. So the main thing. So let us say that the full self-driving problem has been solved, and the vehicle is self-driving. What is Tesla headed to? So I think it can be software as a service. So at the moment, there are, I think, two, or actually there are many, actually, but the two main one. The AWS gives people space, their data center power for you to do your neural network training. So they give it out as software as a service, or actually they rent it out. So you can imagine Tesla having all these amazing infrastructure that they build for training these large amount of data, hiring it out to people, meaning the only thing that they're going to need to do is to just maintain the infrastructure, because they're the one building the infrastructure. They have everything. But you can imagine now, like AWS and Azure, or these other data centers that, or Oracle, like they have to buy from like NVIDIA and these other, and Intel and these other companies to buy these things, and then customize these things into their data centers network and make sure that they are working correctly, the security level, the efficiency, and like all these things. So you can imagine, as Tesla builds up this Dojo computer, supercomputer, they're going to understand a lot of things in the business of data center management, all the inner workings. And by the time they're solving the self-driving problem, they will have learned a lot of things and improve on these things even better than these other service providers, because these service providers just provides an avenue for people to do things, but Tesla is doing things on their own platform, which is also the difference. So they know what happens, they know the challenges, and they are going to solve these challenges so that when they offer this software as a service, then it will be cheaper. And these can now be broadly given to different people. So it can be companies that are trying to train their neural networks for full self-driving, like other motor companies or other auto manufacturers. You can come to big companies who manage or want to manage their data and actually have analytics. So as Tesla continues with these artificial intelligence problem of self-driving, they are going to come up with different, as we know, Tesla is integrated. So any solution they have will have to be their own.
Yeah.
So they're not going to say, we need this and this and this from this. No. They are going to solve it from bottom up approach. So build it and then work on that, improve it. So by the time we get there, the Dojo D1 computer, it can be sold to other people, yes, but Tesla will be managing how efficient it's going to be and stuff like that also. They can build another side of business of Tesla, of chip making, not just that one, because they have the FSD hardware already. And once this is done, they can say, okay, we are massively producing the FSD software, the FSD hardware, and also doing the data management in our center. So if you want the FSD hardware to use in your other business or in other things or in other machines, then here we go. Yeah. So I think they're building actually a different segment of their business away from batteries, motors, and also the electric vehicles, the electric vehicle aspect of Tesla. Like they're building out these other great business from the other side.
Okay, well, you gotta tell the big story though, and that is Tesla bot.
Yes.
The big reveal. I think the thing that a lot of people were speculating if there's going to be something like this, but it
Yes.
was definitely not something they had to do. It was a big deal. It was like one more thing, and then it's the iPhone, right?
Yes.
Um,
Yes.
what are your thoughts on Tesla bot?
So Tesla bot basically to me, it was something actually that personally I didn't expect, but people had earlier spoken about it. Even before the AI day, they had said, okay, they're going to give out this humanoid robot or this human robot, but we were speculating that this might just be information that will not be true. Okay, so for the humanoid robot or Tesla bot, I think it's it's just something else. I wasn't expecting them to do that, but it's okay because when you look at the Tesla bot, basically, whatever is going to the Tesla bot is going to have, they will be having cameras. So the cameras, they already have the cameras. The neural network training, they already have neural network training,
Yep.
and the other things like they have everything. The only thing is they have to put it together and now learn the world like in a different way, not like a vehicle, because the vehicle has to learn like these the traffic lights, these are the situations in a road, and the road has roads. So for a humanoid robot, it has to be told like do this, like we want you to live this and this, like boring tasks. They're not going to get tired, and I think the mechanization of Tesla, or actually the use of robots in Tesla factories, had made Tesla aware that there are things that human beings get tired easily to do or get bored. So you if you are going to be lifting boxes like this, you will get tired, one, and two, it will get boring.
Mhm.
Once it gets boring, you will not be efficient. So, but for the robots, I think in the long term, the Tesla bot is going to be a money maker. But I think mostly right now, it's just going to be just in early stages. Like probably Elon Musk is trying to do this by using the data that we have or that Tesla has, but it can be applicable only in one place, manufacturing and stuff like that. But we already have robots in manufacturing, so it doesn't have to exactly look like a human being. So something now like, let us say, Mars, the moon, or stuff like that one, it can be now used in those specific places.
Yeah. It
Or
did look a
if they are
lot like
dangerous,
Starman,
yeah, exactly. So
right?
if you go like, let us say, to dangerous places or
Mhm.
like extreme places, I think you can use the Tesla bot in those situations. And
Yeah.
but I don't think it's going to be any money making machine for Tesla in the future. But it can be, because you can look at how efficient it's going to be. But also it will depend with the mechanics of when they are going to reveal next year now, like and to reveal the prototype of the Tesla bot. But for now, it was just more like fanfare, like we can do this, and actually they have the resources to do it,
Yeah.
because the cameras they have, the neural networks, the models they have. The only thing now is, you can imagine, once the Tesla bots are out there, they are going to study the world now in a different dimension, like the way a human being can see things. Like when you see something ahead of you, what do as a human, but as a human being, not as a
Yeah.
vehicle? So I think it's really going to be like, probably Tesla wants more data about the environment. So if you can have a lot of data, let us say within like a person, then it means if you can retrain these neural networks as a person, it's going to change a lot of things, like even improve the Tesla vehicles, because it will be looking at things in a perspective that a human being can look at things. But for now, I don't think it's a big deal until we have the prototype and see what the prototype can do.
Yeah, one thing that went through my head when they kept saying boring, repetitive, and dangerous, which
Yes,
BRAD. So it's easy
yes,
to remember. Anything that's Brad, they're going to get
yes,
them to do. One thing that I've often thought about robots and I'm talking about the standard industrial robot on a pedestal that's,
yes,
they are extremely expensive. And
yes,
my theory is that they're extremely expensive because they have to be extremely strong so that they don't wobble,
yes,
and they have to be extremely precise so they wind up exactly where they're supposed to.
Yes.
But if you look at the tool at the end of the robot's arm, it's usually something that you or I could lift.
True.
And we could accurately position it because we have feedback. We're made out of jelly, but we can still put the screwdriver into the screw hole, right?
Yes. Yes.
They have to have a machine that weighs 2 tons to do the same thing reliably.
Yes.
But this is maybe the first effort, but you could imagine they just take the arm off of the humanoid robot and have it do things much cheaper than that 2-ton robot.
True.
Right.
Yeah.
So that's one aspect.
Yes.
The other aspect of Tesla Bot that got my wheels turning is you keep hearing these deadlines, like we have to go to Mars in 2024, or we have to go to Mars in 2026. And the reason for that is because if you don't go at a specific time, the transit time is much longer.
Yes, true.
Well, the robots don't care.
Yeah.
So you could send to Mars, and if it's Elon time, it's Elon time. But anytime you're ready to launch, because I don't think you've maybe there's more propellant required, more delta V to get to Mars at the wrong time.
Yes.
But they're putting the biggest robot ever conceived together right now. So I don't think delta V is a problem. The third stage can take you all the way to Mars.
Yes.
Or they can even just refill the Starship.
Yes, they can refill.
I think you're going to see robots on Mars in about 3 years.
That is exactly when I saw the Tesla board. That was the first thing. I think the next place they are going to go, if they will be here by, let us say, next year or by 2022, then they can be sent to the moon. Sure. Because I think the next destination that people are going is the moon.
Yeah.
For proof of concept. But I think at the end of the day, these machines, I think, will go to not just the Mars, but it will go to different places that human beings cannot go. But when you go to a place and you have the human brain, it is not like going to, let us say, Mars at the moment. You just put the data that you have and store it somewhere and expect that maybe one day when people will go there, they get the data and then send it back and come and do it. If you have a robot, like a human robot, that can think like a man or like a human being, then it's much easier even to look at various things in Mars or in the moon, and you can leave them there to stay. And then the thing that you're going to look there, like I think the most important thing about the humanoid robot that Elon Musk unveiled was it can be applied in a lot of ways, but here on Earth, not so much, but the information that can be collected by the robots, I think, can be useful in space, Mars, or in other regions if we are going to study other things.
The other thing that crossed my mind is there might be a connection between Neuralink and Tesla Bot. That one of the advantages of creating a self-driving fleet of cars is millions of us are willing to drive around with it in the passenger seat, learning from us.
Yes.
One way to do that with a robot would be, not today's Neuralink, but if Neuralink got to the point where you could convincingly interact with a first-person shooter, right?
Yes.
Well, why not have the robot be actually walking around your house and you're walking through the game?
True,
right?
True.
Go get me a beer. If I'm confined to a wheelchair, now I have somebody who can go get me a beer from the fridge.
Yes.
Right. And every time it stumbles on the stairs or has trouble opening the fridge, it has to get out of the way because the door swings this way. Every lesson it learns could be part of the feedback. The problem is you won't get millions and millions and millions of miles.
Yes.
So I don't know. So that's one challenge, but I think that Neuralink could be a really easy first step, or not easy. I shouldn't say easy, but an interesting way to get a little bit of humanity inside the robot.
Yes. I hadn't even thought about that, but I think that would be the easiest because if in Neuralink you have to integrate, you can connect to the computer, and I think that is the basis of Neuralink, to connect your brain to the machines that you have around.
Yeah.
So if the humanoid robot can be a machine by then, which is a machine, then you can do what?
Yeah.
You can link with them and then let it do stuff that you think. So if you think of something like, I need some water, It can go and bring you somewhere. And the robot even cannot just be so big. It can be made to be smaller so that it can do tasks around the house easily and quickly. That maybe you want to do this and that and that. But I think that is not for the next, like, probably
that's going to be a while.
8 years. Yeah.
But I also, the other thing that there's a something called a von Neumann probe. It's not a real thing, but it's this idea that you can send a probe into space that will chew up meteors, get raw material, and build another probe. And so you can explore the universe by self-replicating machines, right?
Yeah, yes.
And it seems to me that you could send 2 robots and a box full of robot parts to Mars.
Yes.
And it might be more compact, right?
True.
And there may be some materials on Mars that are easy to collect that would contribute to the construction of the robots. I think that's a long shot for the first mission.
Yes.
But I can see that, you could, I mean, the people who are critical of Elon keep saying it's ridiculous. We're never going to send 100 people to Mars in a Starship.
Yes.
I kind of think they're probably right.
Yes.
But there's also the possibility that once Starship gets into orbit, it can be inflated and expanded and build out. But never mind that. You could probably put 10,000 robots in that.
Yes, and send it to Mars.
They don't need to stretch on the journey.
Yes.
So
true. And also you can use robots now to build like the Mars infrastructure. So before people gets to Mars, you can use robots to build the infrastructure, to test the air, to make sure that everything is working correctly before people gets there. And people like mostly what fascinates me about people who doesn't like Elon Musk or who say Elon Musk does this and that, like, these are pessimists. They don't see the future like the way other people see. And if you become a pessimist, too much of a pessimist, you will never see the future. And a lot of people who hated Elon Musk, they say that, okay, Tesla will never even make like 1 million vehicles or 100,000 vehicles or 50,000 vehicles. Once they get to 50,000, they say, no, it's so expensive. Once they reduce the price to 39,000 or 40,000, they say, no, even the battery that they're using, it's coming from this and this nickel and this. Elon Musk changes the battery architecture of Tesla into things that can be easily gotten or actually can be easily found. They say, no, Shanghai is going to be hard. Or, okay, the Giga Berlin, they're building a lot of factories. The company is overflated, or actually the share price is so inflated, blah, blah, blah. Like, if you're a pessimist, you will not lack something to say about something that is negative.
Yeah.
But at the end of the day, Elon Musk is advancing his companies. Elon Musk is like, I even wonder, like, what is the cost if Elon Musk make a humanoid robot? What does it cost you? Absolutely nothing. Yeah. If you're a Tesla shareholder.
It's funny because people are both upset that he's going to fail and upset that he's going to succeed, right?
Yes.
Not only won't it work, it's going to take all our jobs. Like,
it's okay. It's okay. It's going to take like even at the moment right now. Like, I think the most important thing about human advancement is not to look at things negatively. As much as it is going to, there are jobs that are going, there are jobs, hundreds of jobs that have been taken by robots up to now.
Mm-hmm. Yeah.
And I don't think that at the end of the day, the problem, or actually, the people who are rendered, let us say, rendered jobless by robots that are doing rounds right now, they got something else to do.
Yeah.
I guess. If not, then you just change. Like, at the end of the day, these things are going to happen, and they are bound to happen in every generation. And if you get bitter, and because technology is like, change will come whether you like it or you don't. So even if you delay it, you can delay it, but it will come. Yeah, you can delay, but it will come.
I do think that whether we agree on timelines, I think it's inevitable we're going to send somebody to Mars. Whether we agree on timelines, I think we can agree there's going to be self-driving cars.
Yes.
The optimism you and I feel in terms of how quickly that will happen is part of the problem I think that people are alarmed by, and that is, sure, farming went from 50% of the population to 5%, but it did it over 100 years. And people had time to work at Starbucks and work in
Yes.
universities and work in tax preparation centers. Like there were
Yes.
things that they could find to do. But if
Yes.
it happens like that, that's scary because now you've got so many people affected at once. So
Yes.
there needs to be, you know, I'm fond of capitalism, but as soon as I say anything that sounds like we're worried about the collective good, it's like you're a communist. The thing is, there's something in capitalism which says the winners need to take care of the losers. Like you can't just
Yes.
let all the money go to one group of people. So
True. True.
I think we're going to have to be more open to solutions. I don't think it's necessarily universal basic income, but there has to be
Yes.
support for people who are affected by this.
Most
Um,
definitely.
but before we wrap up, because I've kept you a long time and it's been a
It's
great
okay.
conversation. I appreciate it. But
Yes.
you and I are obviously both optimistic or see a bright future for what Elon's doing. But there are, I thought, some things that happened or some things that were revealed in AI Day that were interesting that gave me that maybe go,
Mm.
okay. And I want to see if you picked up on any of these. One of them was that he said that you're going to be able to get into a full self-driving car and say, I'm in a hurry, get me to the airport quicker.
Yes.
Do you think that's a risky setting to put in a car? Because the car, if you say go as fast as you can and the car gets into an accident,
Yes.
who's at fault? The person who turned the dial or the person who designed the car?
I think it would be simple. For me, though, I think it's possible for you to tell the car, I want to get to the airport as quickly as possible, or I'm in a hurry. Because at the end of the day, the vehicle can choose which is the way to go. You can go the longer way, faster, or you can go to the near way, slowly. So it will be just choosing of like or actually making like options, like what are the options that the vehicle has, of what speed, like do you want me to get there, or in how many minutes do you want us to get there? Is it really possible? Then yeah, but as time goes by, I think the vehicle is going, but I think that is true. It can happen. I think I know that it can happen. It will happen definitely, because sometimes you want to maybe go and pick this and this, but if you want to go straight to the airport, like which is the easiest way, and I think that happens right now with Google Maps. You just tell Google Maps, I want to get there, so it gives you the different options,
Right.
which one is easier to get,
Okay.
which one doesn't have traffic, which one, like these are the options that you cannot know offhand. Like you cannot know, like if I go with this, there's traffic there. But if it's if it's like they already know that we have traffic in this road, we can go through this and then come this way. Like I
Okay.
think that will be much easier. Like
Yeah, I
for me,
take your
it will
point.
happen.
So what you're not choosing between safety and speed. You're choosing between economy, comfort, and speed.
Yes.
Yeah. Okay. Um, the other thing that gave me pause
Yes.
that I didn't and that was like was when Elon was asked how he would scale the production of Tesla bot, and he
Yes.
dismissed the question. He says, "Well, I guess we'll just have to see." And I thought
Yeah.
that was a little rude and a little dismissive, but I also think maybe for once he wants to
Yeah.
keep something secret.
Yeah, you want to keep it secret, and also like probably he doesn't know how this can be scaled, because you cannot think of scaling something that you don't even have the prototype. And once
True.
you now have the prototype, you know like the mechanics of building these things are this and this and this. And once the prototype is built, you can now like guess like, okay, we will know how this and this happens. Because at the end of the day, if it's just a concept, the concept is there, yes. But now what are the mechanics of building this? Where did we get this? How do we get this? How do we make that sure to make sure that the glass that is in front of the humanoid robot can be clear, and the humanoid robot can use the cameras to look at whatever is happening here. And I think they say for the humanoid robot also, you can read from the face of the robot that there is this and this and this that you need to do, or you have to do. Like at the end of the day, until we get all these various points, and with a prototype that we can, okay, these are the challenges. So I think basically Elon Musk was saying like, okay, we will know once we have the prototype, maybe.
I just I don't know what it was you said exactly that made me think of this, but there
Yes.
are some parts of the world where if you pull up to a stop sign, somebody
Yes.
will rush out and try to clean your window for money.
Yes.
Are you familiar with this? Does this happen where you are?
Where I am is mostly when you go to a petrol station. So
Okay.
once you are waiting for your vehicle to be fueled, then I think there's some guys who just swipe your
But they
screen.
work for the gas station, right? For the petrol
Yeah, they
station.
work for the
Okay.
gas
I'm talking about
stations.
people who don't have any job, but they
Yes,
basically, instead of begging for money, they go out and they
yes,
clean your windshield, and then they're like, now you owe me money.
yes,
I just
true,
had
true.
this mental picture of
Yes,
Tesla bots with
yes,
no job, and they will go
yes,
clean the cameras on your Tesla so it can keep driving even though it's
yes,
snowy or dusty. That, I don't know.
yes.
I just had this mental
It,
picture
it
of that.
it can happen. It can happen. It can happen. I think the most important thing of the Tesla bot is it's not something that cannot happen, but it's also something that has never been done before. And I think it's possible. I think Tesla can do something big with it because they already have nearly all the components that
Mhm.
can make it so human.
Yeah,
They already have the data of how human behaves in certain situations when you're going, like when you're moving, when you look at this person and this person, like they already have a data set of situations that and how human beings behave. And I think in the long run, the Tesla bot is going to be brilliant. But the first thing is let us get the prototype. Once we have the prototype, I think I can even say a lot of things about the Tesla bot. But for now, I think it's just an idea that is there. And once the prototype is out, then I think that would be I will be in for it. But
yeah,
I think it will just be useful in mass, probably outside, like in just situations that I don't think people will be walking because I can't imagine myself being in my house and then the robots is moving from this side, this side, this side, this side. Like sometimes you just need that peace that you just sit down. You don't want to see
sure.
anything going around.
Um, Another part that made me go,
Yes.
is when Elon was asked if they would be using Dojo and machine learning to revisit the idea of the alien dreadnought. So this idea that we're going to have a manufacturing plant
Yes.
be you can turn the lights out and all the machines just keep working, right? And
Yes.
you pour
Yes.
material in one end and cars come out the other, and it's all automated inside.
Yes.
And famously, this didn't go very well.
Yes.
And they wound up really, Elon said, humans are underrated
Yeah.
and put more humans back into the process. Now, he challenged the premise of the question by saying, sometimes I say things and people think they exaggerate. I
Yes.
said
Yes.
so much of what we do is automatic. Some things are
Yes.
still manual, but not very many.
Yes.
But then he said that he really discourages machine learning in manufacturing. He called it BS. He actually used the whole
Yes.
phrase.
Yes.
And to me, that seemed like once bitten, twice shy. It didn't
Yes.
seem like first principles to me. It seemed to me like it
Yes.
didn't work over here, so it won't work over here, which is out of character.
Yeah, yes, I think it's true. It's true. I think Elon Musk learned his lesson like back then when Tesla was struggling. Like because at the end of the day, there are things that human beings can do better than robots because robots are just like as you said, I can bend my hand like this and put something easily. I can connect something like just put it like just as simple as that without a lot of thought into it. But machine has to process the code, say, okay, this is the code, this is what I should do, this is what I should do. After this, I do this. No. But for us, it's just simple. Just have this, like this bottle of mine, open it, close it,
Yep.
just like that. And it's automatic. So I think what Elon Musk is saying basically is it's and human beings, as you said earlier, are underrated. And he doesn't want to get to that again anymore. I think
Yeah.
the only thing the only thing is just want to improve on what they have built and then build further. And I think the next thing that they're going to do is probably add another company. Yeah, not another company, add another factory. I think probably 2 or 3 factories within the next 3 years. Probably add one for manufacturing these chips and data centers if they're not going to make it in New York. Like there are a lot of things that Tesla can do at the
Mm-hmm.
moment. And one of them is because like today we saw a vehicle that has been the Model Y that has been made already in was it Texas or in Austin? Not Austin, in I think Berlin.
Mm.
So they have these things rolling out. So already Tesla has figured out all these things. They already know, like, these are the situations, building factories. So Tesla is now going to build a lot of factories quickly and
Yes.
cheaply than
Yes.
they've ever done. So I think the most important thing for me for Tesla going forward, and what I learned from the AI day, is that Tesla are not backing down from their vision, that the vision approach is the only approach to solving of full self-driving. And it's so important that they lead to that, and they are going to put in everything they can to that. And the most important thing that I realized also was that Tesla has brilliant people.
Sure.
They have the best engineers, like the best leadership from Elon Musk. And that makes people like learn from mistakes, iterate, make it better, learn from like what is the main problem, the first principle approaches and stuff like that one. Like and that is so different from Tesla as compared to other companies. Like they learn from the situation that they are in, and then they move to the next. And you used to say it earlier, like for Tesla to make 2 million vehicles by next year, like these are the different facets of Tesla that people usually think Tesla is just an ordinary like auto manufacturer. But Tesla is not an auto manufacturer even to begin with. As Elon Musk said, they just like they are an artificial intelligence company. They're a robotics company, in short. So
Well, I want to, that was one of the points I wanted to bring up with you.
yes,
Tesla has to date had two mission statements.
yes,
The first mission statement was to hasten the transition from fossil fuel transportation.
yes,
The second mission statement was to hasten the transition from fossil fuel energy. So
yes,
they took, so if you imagine a pyramid or a
yes,
triangle, like this triangle is the vehicles. And then they said, okay, it includes this, but now it's going to be all energy. All energy is
yes,
going to be electric.
yes,
Because that is at least it's progress on the same line.
yes,
Now they're going into FSD, and I understand why. It's a huge opportunity. And
yes,
now they're going from there into AI and into robotics.
yes.
They're becoming General Electric. And the
Exactly.
problem I have with General Electric is they don't have their mission is to make money.
Yes, yes,
And that's when things start to fall apart. Then people just start looking at balance sheets. They don't look at what the future holds.
yes,
What can Elon do to
yes.
describe Tesla now that keeps everybody focused?
I think that the thing is I think Tesla basically, even Elon Musk cannot define like exactly what Tesla is doing at the moment. I think the first the Tesla part, like the master plan, the first secret master plan was achieved by 2015. And I think that one, after the first Tesla secret master plan, the second master plan, the part two, I think brings now into all these sections that we are seeing at the moment with Tesla, which means that it's energy, getting into energy storage, and mostly energy storage. I think previously the part like the Tesla Secret Master Plan Part 1, it was about like solar energy and making that the transition into solar energy to electric vehicles, the battery manufacturing and stuff. But right now, Tesla has figured out battery manufacturing. They're still figuring out solar, but they have solar already. And what they did in part two, they say that they want a fully autonomous vehicle. And that is now what is heading, that is making Tesla now get into AI. That is what is getting Tesla into
True,
AI.
but the self-driving thing to me was the natural end game to cars becoming electric.
Yes.
And in the end, a natural outcome of that is we don't bother to own cars anymore because I don't own an elevator. I just get into one.
Yes.
It takes me where I want to go. I don't think.
right?
Yes. Yes.
I think they're getting bigger than that. So it's time for part trois, right?
Yes.
Part
Yes.
three,
Yes.
the
Yes.
master plan part three. And I wonder
Yes.
if he's going to get himself, because we talked about the Solar City merger.
Yes. Yes.
What happens if part trois merges Neuralink and Boring Company?
Wow. It will be something else. It will be a
People's
different,
heads are
like,
going to explode because he
yes.
is so involved. He's already in court because of Solar City, but
Yes.
I don't think I honestly don't think he cares. Like, he's already very rich. I mean, he cares. He'd rather, if he had $1,000 and Jeff Bezos had 900, he'd be happy.
Yes.
So I don't think he's not competitive, but I don't think it's the money that motivates him.
Yes.
I think that he would be frustrated if there was a way to connect, just like with the Dojo tiles connecting, right? He wants
Yes.
to have
Yes.
maximum bandwidth.
Yes.
You can only have that if they're in the same company.
Yes. True.
And so he's going to want to, I think, with this robot and with all
Yes.
I mean, he's using the Boring Company to connect factories to suppliers. That's the theory.
Yes.
People are saying he's going to do that.
Yes.
It's all starting to come together. So he needs a part trois. He needs to
Yes.
articulate what the vision is. And I think he's
Yes.
going to try to embrace those two companies.
True. He will do that. And also, I think that we will have part three probably in the next 2 or 3 years. Once they've nearly nailed full self-driving, because once they're done with nearly nailing full self-driving and they are making, let us say, 1 million or 2 million vehicles a year, then that is game. Like, Elon Musk doesn't have a lot to do in his plate, because if FSD is nearly being solved and every day it's improving and getting better, SpaceX is doing its thing. I think the only focus that Elon Musk is going to focus on next will be Neuralink and I think Boring Company. But mostly at the moment, Elon Musk is even more free. You find him moving this, going here, coming here, like moving
Sure.
around, having free time.
Sure.
And like because they have nailed, like, what was the main issue with Tesla earlier? They have nailed it. And the issue that they have right now for full self-driving, once they nail it, or nearly, they just have a small portion to finish it up, then I think that will be good to go. Elon Musk will now concentrate on part three, which, as you said, will integrate most of these companies. And when you look at like the Cybertruck at the moment, Cybertruck, the steel that is being used in the Cybertruck, the technology is the one that was in SpaceX.
Okay, so when does SpaceX become part of Tesla?
That is now for like 2030. I
Or
think from 2030,
does it become like Alphabet?
that is exactly what I'm thinking, because I think mostly the main thing right now is, if Tesla nails full self-driving, they have nailed the electric vehicle. They have the electric vehicle market, let us say 30 or 40%. And they have nailed full self-driving. Once you nail full self-driving, no one will want an ICE vehicle first. And people will need the FSD, because once you get you seeing people using FSD, you're still driving personally. Like, once Tesla nails FSD, it's like the best marketing platform they've ever had. And no one will ever get there, because they have the autonomy, like they have all the data that other people doesn't have. And even when you come to competition, like, can Tesla be forced to give out their data to the competitors? I don't think so. And a lot of people would, just like Apple at the moment. Apple doesn't sell like a lot of phones as compared to Android phones out there, but they make a lot of money more than these other companies. So I think Tesla will also do the same. Tesla will be the what do I call it? Will be the best in the market that people will use to say, okay, this is the best, this is second. But I think data is important. When Tesla nails it, they're good, and they're going to bring together. But the one that they're going to bring together mostly easily will be the Boring Company, because they already have the Teslas running in the Boring Company halls or in the Boring Company tunnels. Like,
yeah.
And after that, they're going to make now something specific to the Boring Company, probably like something like a bus.
Right.
which might not be a bus, but something that looks like
Sure.
that. Like, I think the as you say, the most easy one that they can integrate quickly is that one. And probably Neuralink, I don't think they will do that, but that one and this other one, that was okay. Then probably from 2030 now, once SpaceX is now going to Mars regularly, then if they can link it with Tesla, then that's okay, because if you go to Mars, you get a Tesla to Mars.
Sure.
Or a
Get the
vehicle to
Tesla
Mars.
robots to Mars. I actually think that Neuralink is a good fit for Tesla because
Yes.
of the AI.
Yes.
I think that the signals that come from the human brain are
Yes.
mysterious, and the pattern can only be learned. You can't program to it.
Yes.
And so I think that if we want to interpret the signals and also create signals that are understood by the person with the Neuralink,
Yes.
I think some processing by neural networks would be really useful. And so that could be
Yes.
part of the project, that because, as you say, this was a recruitment effort. This is the toy
Yes.
box
Yes.
of all the things that we're capable of. Where else would you want, where on earth would you like to work if you're into machine learning? You have cars and robots and Neuralink and also Dojo to play
Yes.
with. I mean, it's an
Yeah.
incredible opportunity.
Yeah, for most engineers.
I promise you, we're getting close to the end here.
Yeah, it's okay. It's okay.
There was a question raised where basically they were saying that even with the computer, the supercomputer, the training computer they have now, they're able to create larger and more sophisticated models.
Yes.
They have all this data. They can make a very sophisticated model that will address any situation that has been seen in the data.
Yes.
But you can't put that model, you have to distill it. You have to simplify it to put it into the car for a couple of reasons. Power consumption,
Yes.
speed, like the latency. You can't have it freeze for a second and think.
Yes.
And so it says to me that whether hardware 3 is enough or not,
Yes.
you're going to want a better hardware than hardware 3.
Yeah.
And Elon said,
Yes.
well, it's going to be better than a human.
Yes.
But if it's not as good as hardware 4, which he said was going into the Cybertruck,
Yes.
people are going to say, I'm not sure if I want to be driving in a car with hardware 3.
Yes.
I want hardware 4. And people are going to say, but you sold me this car saying it was feature complete.
Yes.
I think there's going to be, because that's what I was hearing on Twitter, is people going, he promised. I spent $5,000 and I don't have anything for it.
Yes.
There's going to be people who are angry. What do you think? Do you think that's a real problem? Or do you think that as they get more sophisticated at producing neural nets, they can make it function on hardware 3?
No, I don't think it's there. I think even Dojo, once Dojo will be here, I think they say Dojo will be here by next year.
Mm-hmm.
So, and by next year, that the hardware 4 will be in production, and also the Cybertruck will be in production. So mostly what they're trying to do is to make sure that all vehicles that are going to come after this. So right now, Tesla has about, is it nearly 2 million vehicles in the road at the moment? Probably. But by the end of next year, they will have more than 2 millions in that particular year than the history of Tesla. So for the people who will be having the hardware 3, I think they can upgrade to the hardware 4.
At whose expense?
Or, yeah, and I now don't know if they can work something out, then I think for everyone, it will be happy for everyone. But I don't think Tesla will take the cost for that. But if they can also take the cost, then it's not a problem, because people who have purchased FSD, I can't say nearly 2 million vehicles that are out there. A lot of people purchased FSD, all of them, nearly half of them. I don't think so. So even if Tesla takes that cost away and give them the hardware for full self-driving, then that would be okay. I don't think it's going to be so big of a deal. I think people are just right now, they are frustrated that FSD is not yet here. And what if this better chip comes in? At whose cost are we going to replace it? Am I going to be I think there are people who are given the chip, the hardware 3 free, if I'm not wrong.
Well,
Like
I
the
think you're
replacement.
right.
The
I think
replacement.
every car has every car produced since a certain date
Yes.
has had hardware 3, right? I think you're
Yes.
right.
Yes.
What hangs in the balance is they bought
FSD or
they
not.
bought FSD before it even was in existence.
Yes.
And for $5,000, I'd
Yes.
be like, okay, like now it won't work on my car at all.
Yes.
I think we're going to see some trouble there. I think.
Yeah. There might be some trouble, but I think it can be easily solved. I don't think it's going to be so
I think
big
it
of
can
a
be
deal.
solved, but it can be solved for $1 billion.
$1 billion, but by then Tesla will be generating about, I think,
Yeah,
60,
I
70 or
agree.
$80 billion. So
Yeah, but
I really don't.
it's a rare corporation that just says, okay, $1 billion, right?
Yeah, because I think so that, like, if Tesla is planning to have 2 million vehicles next year, which they will,
Yeah,
like up to this year, since 2004 or 2006, when they produced their first vehicle, up to now, it's not yet even 2 million. But when it gets to more than 2 million per year, so, and then by 2023, it will not be 2 million, it will be something like 2.3, 2.5 million.
yeah.
Like the economies of scale in terms of even the FSD, like the cost of manufacture or the cost of producing FSD hardware for, will even be very cheaper to compensate the, let us say, the
Sure.
1 million, let us say at most 1 million people who have FSD. So
Yeah.
I think it will be okay for me. Like, I don't think it will be big of a deal. And I think Tesla will work it out. If you have FSD, if you bought full self-driving, then you deserve a new chip. If the other one is not going to work on hardware 3, or if it's going to be slow or not working as it is intended. So
It
I
would
think the
be
most important,
nice if they took that approach, because I
yes,
agree that if they spent $5,000 on full self-driving and all it
yes,
takes is $1,000 hardware upgrade
yes,
to make that work, you know, it is kind of on Tesla, but it would be an amazing company to just go, okay, like I think it's going to take a lawsuit. I think there's going to be some sort of Solomon-like split down the middle.
yes,
I think it's going to be a little, but here's the thing. The
yeah,
area under the curve is growing so fast,
yes,
right? The number of cars in existence is going up so high that even
yes,
though it will be, I think, not making early buyers happy,
yes,
that will be 10% of the population of people who have Teslas, and the 90% are going to be thrilled.
yes,
So I can see why some people on Twitter are angry anyway,
yes,
because I think
definitely
that the
Twitter.
future is not going to be that easy for them.
Twitter is so angry. Yeah, Twitter is angry. Twitter is an angry place.
It is. I noticed that.
Yes.
I'm new to it, so I'm just learning.
Yes.
When Elon said that hardware 3 is going to be fine, it just won't be as safe as hardware 4, but it'll be safer than a human. I was very,
Yes.
they showed 4 other people on stage,
Yes.
including our Andrei Karpathy and the other gentleman who talked about the hardware.
Yes.
And I watched that clip a few times and I couldn't see a moment where they're like, what? Like there was never, their body language was very neutral. I don't know if that was deliberate, but it seemed like to them, he was telling the truth.
Yes. Yes.
Like I watched that clip really carefully and I didn't see anybody like roll their eyes or look away or anything like that. So I don't know, maybe it's true. Maybe we don't need to worry.
No, I think the only thing is the thing is, when you are told something is better than what you have, the tendency is you want that better thing. So
sure.
Even if it doesn't make sense for you to have the better one, but you want it because that is you being human. Like you want something better always. So even if it doesn't really matter, but you just want it. But anyway, I think it would be something that is that can be solved easily by Elon Musk and company. And the fact that Elon Musk is saying that openly, and the rest, Andre Kapathy and Ganesh and the other gentleman, like they don't even fear anything, shows that Elon Musk is aware of all the challenges of hardware 3. And the reason they are moving to hardware 4 from the Cybertruck already has 1.25 million, I think, reservations. And yeah, it's 1.25, I think, is the reservation. And it's going up every single day.
Yeah.
And that basically means that within the next 3-4 years, if Elon Musk sees that the hardware version 3 is not going to help solve self-driving as quickly as possible, then it will be better to have a model like other models coming forward have hardware 4, if that can make it easy. And then the few, like let us say 1 million or 500,000, I don't know the number of FSD people who bought FSD
Exactly.
but
Yeah,
if
it's a
there are a
subset.
number, yeah, if that subset does have that, and Tesla is already, like, I think the most important thing is economies of scale. One Tesla hits economies of scale in the chip production, then it will be even cheaper to even replace those other chips. Because if I have full self-driving, I want an FSD that is working, and like the one that is outside there for everyone. And I think that it can be workable easily. But Elon Musk is confident. I think the most important thing about Elon Musk is he understands what he says, and even though at times it can take a while for them to deliver, they will. Because in 2018 or 2019, I think 2018-19, when they talked about the FSD hardware 3, I think 2019, they said that they have already iterated on hardware 4, and by the end of 2021 they are going to have hardware 4. And we are in 2021, and they will have it probably next year, so probably a year later or something. But it's okay, because when you look at hardware 3 in comparison with the chips that are out there, it's very competitive. And they say that hardware 4 is even going to be better than hardware 3.
Sure.
Which means Tesla in chip making will be getting up there with the industry, with people whose job exactly is chip manufacturing.
Yeah.
And Tesla is just a car company. That is why I'm so confused about Tesla, because the engineers that they have, the software engineers, the chip architecture engineers that they do have, like, it's like nothing in the market. Like, you go to NVIDIA, they have the best. You go to Intel, they have the best chip makers. You go to, let us say, TSMC and anywhere else in the world. But Tesla, a vehicle manufacturer, has this best talent, and they coming up with these products that are top notch. And I think it's so important. Like, the reason why people are working in Tesla, most of these big engineers, is they understand the vision, and they believe that the Elon Musk and the company will give them resources to make sure that their potential comes out. And that is so important. If Tesla is to solve FSD, they have to bring in the best talent outside there. And I think they did their best. And I think a lot of people will be applying for the Tesla AI team and all these other disciplines from Tesla, like from battery technology, motor like technology, like all the aspects of Tesla. And I think that is so important. As much as Elon Musk is becoming can talk a lot, but I think he attracts a lot of people, a lot of brilliant people and brilliant minds.
So another moment that got me was when I don't know his name, but he said that he was excited about the Dojo's future because they would first focus on FSD, but then they would focus on Optimus.
Yes.
Oops. Because Optimus was the code name for the Tesla bot.
Yes.
And generally speaking, you're not supposed to reveal things like that. But it didn't, again, not everybody on stage was like, oh, that guy's going to get force choked by Darth Vader later today. Right?
Yes.
Like, I didn't get the impression that they were afraid of Elon.
No, they're not.
And I realize that they're at the very highest echelon of the company. I mean, they are the best of the best.
Yes.
But he has a reputation for being hard to work for. I didn't see that in the body language on the stage. I mean, here's a guy who made a mistake and revealed something that wasn't planned.
Yes.
And Elon's just making a joke about it.
Yeah. And I think that is the good thing about Elon Musk. I think Elon Musk, most of the people who have worked with Elon Musk for quite a while, they earn the respect from Elon Musk. And Elon Musk is just that person. Like, if he thinks you carry it, and everyone else, even Elon Musk himself, has shortcomings, and he knows that. And at the end of the day, what matters is the work that these guys are doing, the effort they are putting in, the teams they are leading. And if Elon Musk would have said, like, wants to fire someone, or because of saying something like that, these are people who are leading teams, and I think the people who are behind these guys will not love that, and it's going to bring something else. But I think Elon Musk over the years have learned that as much as in people can do things that you don't like, but at the end of the day, you have to move on from that and look into the brighter side of it and the better side of people. And I think the fact that people like Drew Baglino, people like Andre Kapathy, people like Ganesh, people like most of the guys that are top notch at Tesla, I think are brilliant and smart people, and they have earned the respect from Elon Musk, and that is so important. And I think Tesla's hiring team are actually the best. I don't think there are people who hires people right now like Tesla does, because they get the right people, and people are motivated to make things happen, not for the sake of money or anything. And I think that is so important if you are to solve problems that are out there.
Okay, I'm going to bring it home. I'm going to ask you for 3 predictions.
Yes.
And then we'll call it a night. So when will FSD be usable, and what's your definition that says it's usable?
So FSD, I'm giving it the next 3 years. So it's the end of 2024 going to 2025. It should be workable. Yeah. And what is workable for me for FSD is once it gets out there and it does exactly what a human being can do. And I'm very sure that it can do that and even better than that.
Okay.
With the best, with just integration, the right integration, I think that can happen.
So here's the I may regret, who knows, if I'm wrong, I will regret this, but I've said publicly,
yes,
some jurisdiction around the world with 1 million people in it,
yes,
by the end of 2023,
yes,
will allow people to sit in a passenger seat,
yes,
of a Tesla full self-driving car,
yes,
and that therefore there will be millions of people or millions of trips done that way, and they will prove to be safer than humans.
Yes.
So I'm more optimistic than you, but I'm not saying worldwide. I'm saying one jurisdiction, and if I had to really be pushed, I would say somewhere in China.
Yes, most definitely. I think in China, people are so open to new technologies, and the government, once the government says something has to be done, it has to be done. It can be done.
Right. Yeah.
Without a lot of people going to the streets, people posting online, going to court and stuff like that. Yeah. So for the reason why I'm pushing it to end of 2024, 2025 is first things that I want is the hardware to be here.
Mm-hmm. Mm-hmm.
So, and then have a lot of vehicles
Dojo
out there with hardware
Yeah.
And then once that one is done, then at least I give it a year or 2 for now to nail it quickly.
Right.
So I think by 2024, end of 2024, 25, it should be okay. And even in the US, a lot of people will be using the Tesla, like FSD, because if you can just sit in your vehicle and just be touching and then it's going, that's okay. But I think the issue with the US and most Western nations is people are so reserved, and people who doesn't even have Teslas are will take up arms and say, no, we don't want FSD, and people who have not used it, if you see the issue that is happening in Berlin at the moment, because I think Berlin Tesla Gigafactory should be working right now, but because of the court cases, because of regulatory frameworks, because of blah blah blah, it's taking a long time. And there's someone, Stanley Monroe, was saying, actually, I think 3 days ago or something, he was saying he was so angry about whatever was happening, and he was saying it right, because the more you're doing these regulatory frameworks, you are delaying things that should happen, and in other nations these things are happening. So there are a lot of things that people look at, and I don't usually love looking at geopolitics when it comes to technology and stuff. But at the end of the day, you find that most technologies that are happening right now, like the cutting edge technologies, if it's not in Israel, it's in China. Like it's just as basic as that. Because in Israel, once the concept has been proved, people are given the opportunity to use it. In China, the same thing, because the government is behind the people, and the government is behind the companies that are working on these things. And if you stifle the growth of the companies that are trying to push forward, you are frustrating. When we frustrate people who are open-minded and looking at solving real-world problems, then you are like making your country at a disadvantage compared to other places in the world.
So I prefer living in Canada to the idea of living in China.
Yes.
In part because the individual is taken care of, sometimes at the expense of the collective.
Yes.
And China, it's the opposite. The collective is taken care of at the expense of the individual.
Yes.
And I do accept the idea that if you prioritize the collective, you can make greater progress on some things, but individuals will be hurt along the way.
Yes.
In a way that you can't predict or prevent to yourself. So, oh, I'm sorry. We did it a little early and it ran over a bus shelter full of people. That's China, right?
Yes.
So the reason I said that China would probably do this first is because they will say, look, it's 10 times as safe.
Yes.
And collectively, that's better. And you don't get to sue if you're one of the people who gets hit by a Tesla now.
Yes.
And so I'm sorry to the people in advance. We know this is going to happen. Somebody's going to get killed by a Tesla, right?
Yeah.
But what that creates is a laboratory where it will turn out that it's 10 times as safe. And then the rest of the world, I said it's going to be like dominoes. Other jurisdictions are going to say, this is an easy way to deal with our traffic problems. An easy way to deal with smog problems. We can say, okay, look, downtown Toronto, it's only autonomous EVs and that's it.
Yes.
And then because they can platoon, they can give each other right away very efficiently. You could have twice as much people getting to where they want to go in the same amount of time. Right.
True.
So I think that it's going to happen. But I just don't want to accidentally imply that I wish I lived in a totalitarian state. I really don't. I just think that that's a likely starting point to something that will be beneficial for a lot of people.
For everyone. Yeah.
So,
and I think you have, as you have said, like when you look at the various technologies that are out there, like mostly it should be like even the internet itself came from the military. And then it now gets to different people that can be used. Like if it was up to other people, they would say, no, this has to stay this way. Like I think at the moment it's good to be cautious at the same time, but also be cautious not to stifle like advancement of these new technologies. Because when you look at other things, like the people who are using drones in war and stuff like that one, you believe in drones, but you don't believe in autonomous vehicles. Like, what is so different?
Yeah,
like,
I mean, I think
it's about the
airborne
acceptance.
Drone is a little easier because you don't have to worry about curbs and stop signs and other traffic, right? Like the air isn't as thick with objects as the ground.
And they use GPS probably, maybe. But at the end of the day, if you don't like practice this or actually make these technologies be applied in real world, then you are stifling the growth. And then as much as accidents will happen anyways, even if there is no full self-driving. But I think the comfort and the bureaucracy that we are seeing in, let us say, Berlin or in whatever, like bureaucracy kills these companies. The companies that are killed by bureaucracy, people who are like, they don't even own a Tesla, but there are people out there who just who spreads the misinformation that that car was killed, like the incident that happened above a Tesla vehicle that had two owners inside, or actually not, that had two people inside. People were saying the self-driving, it was in full self-driving, and no one even knew that it was in full self-driving. And even the Tesla data said no, they hadn't even had that one. And even FSD cannot go in that speed. But people are already saying what, like, FSD is bad. It kills people. Like, at the end of the day, that happens. And it's very unfortunate if it gets to that. And even if it's me personally, like, if it affects me, like, I will feel so bad and sad. But then again, that doesn't mean that the technology is bad.
Sure.
Because I know of a lot of situations that Tesla FSD has saved a lot of people. And it's going to save a lot, because human beings tend to concentrate on and look at the negative aspect of it more than the positive. And
sure.
Yeah, that is the problem.
Yeah, I heard an expression recently. It's called the nirvana fallacy. So nirvana being like the happiest possible, perfectly happy. And so for, people are saying that if you make Tesla vehicles, you're polluting the earth. And we have to acknowledge that's true. It makes pollution to produce any car, but it makes less pollution than an internal combustion engine. So we're not comparing to perfection. We're comparing to what we have today.
Yes.
And in so many ways, depending on where you live, you can be using carbon-free electricity 80% of the time.
Yes.
So an electric vehicle is obviously so much better. Anyway, okay. Two more predictions from you, sir.
Yes.
When will Dojo be complete? The Exapod.
Before the end of next year.
Yeah, I think you're right.
Before the end of next year.
And when are we going to see a recreation of Tesla bot dancing, but it's actually Tesla bot and not somebody in a Tesla bot suit?
That one I would just say, like, let me put that one to 2024, 2023, probably mid 2023, because if the prototype should be ready by next year, I think it will need a lot of stuff to be done. But I think once we have the prototype, I think that would be a good place to start.
Okay.
It would be a good place to start. And then from there now, for Tesla to nail the bot, it will take probably another 5 years from then, 5 to 6 years for you to nail. Because when you look at Boston Dynamics, robots, I think they are brilliant in many ways. I think the only thing that they don't have probably is the data that they need to make sure that they can do a lot of things than they are doing at the moment, and probably the training and stuff like that one. But I think for Tesla, it should be 2023, mid 2023, and then give it 5 to 6 years for them to iterate, see what happens and stuff like that. But if we go to the moon or the Mars in 2025 or 2024 to 25 or 27 or 28, then I think there would be one Tesla bot or two going there.
Yeah, I'm with you on that. I think that's a good prediction, that if there ever is a Tesla mission to the moon or to Mars, it will include at least one, and it might be just a toy, but it will be there will be a Tesla bot on board. I completely agree with that. Yeah.
Yes, most definitely.
I just had a mic drop moment there.
Yeah, it dropped, and I'm like, what's happening here? Let me just place it well.
Well, that's the perfect point at which to end the show, is a mic drop. So thank you very much, Erastus. I appreciate you coming on the show. It's been a great conversation.
Thanks so much, Tim. Looking forward to the next. It's okay. We will probably talk. You just tell me when you're free, then you just tell me, and then I will see. I will be visiting my family probably this coming week and weekend. Yes.
Sounds
great.
I
love going probably once or two. Yeah.
So my guest today was Erastus Kipkirui Laboso. Erastus's LinkedIn address will be in the show notes. My name is Tim Hampton, and you can reach me at tim@leadlikeelon.com. Please subscribe and join me for the next show on how to lead like Elon.